Hey, Professor Baldwin here. Now that we have a general understanding of circles, we're going to take it up a notch and look at some more complex equations of circles and also look at ellipses. Recall that the standard equation of a circle is as follows, with a center at HK and a radius of r. Now, our first example, we're given an equation and we're asked to find the center and the radius and then to graph this circle. Now, notice that the equation we're given isn't in that standard format. So we need to get it into that format so we can easily find the center and the radius. Our first step is to rearrange our variables so that the like variables are next to each other. That'll give us x squared minus 14x plus y squared plus 4y equals 11. Now, we're getting a little bit closer, but these first two terms aren't able to be factored into a binomial squared. In order to do that, we have to complete the square for the x variables and for the y variables. So we need to complete the square twice. Recall when you're completing the square, you're going to take that b value, so for x it's negative 14, divide it by 2, and then square it. So for x, it's negative 7 squared, or 49. That tells us that we can rewrite this as x squared minus 14x plus 49, and that it will factor as x minus 7 squared. Now we're going to do the same thing with the y variable. We take the b, divide it by 2, and square it. So 2 squared, or 4. And that gives us y squared plus 4y plus 4, which factors to y plus 2 squared. Okay, now we have to deal with the right-hand side. We had 11, but we added this 49 and this 4 to the left. So to keep it balanced, we have to add 49 and 4 on the right-hand side. And when we do that, we get 64. Now we're in the standard equation. We can identify our center. That is the point 7, negative 2. And our radius, r squared is 64, so our radius is 8. Now we can plot our center. I'm going to count by 2s. 2, 4, 6, 7, and down 2. So there's 7, negative 2 for our center. Now if I count out by 8 for my radius, that'll give me some outside points that I can connect. So there's 8 down. There's 8 up. There's 8 to the right and 8 to the left. Now, no laughing. I'm going to try to make somewhat of a circle. I draw the worst circles ever. But you get the idea. There's our circle with a center at 7, negative 2, and the radius is 8. Now, why ellipses? Well, if you look at an ellipse, it looks very similar to a circle, just all 4 points aren't equidistant. So we have one side that's kind of stretched out, right? It's like we took a circle and stretched it a little. Now, our first examples are where we have ellipses with the center at 0, 0. So the center of these ellipses is the origin. And notice the big difference between these two ellipses. One is longer horizontally, and the second one is longer vertically. Well, the one that's longer horizontally is called major axis horizontal, and the other one, major axis vertical. So it tells you which way is going to be longer. So major axis horizontal, it's going to be longer along the x-axis, our horizontal axis. Now, if you look at these restrictions for the denominator, a has to be greater than b, greater than 0. Well, A in our major axis horizontal is below the x variable. So that is a big clue to me that this is a major axis horizontal because my larger number is associated with the x. And if you look at the major axis vertical, the larger number A is associated with the y variable. And then you also have the formulas or equations for the vertices, the y-intercepts, and the foci. Okay, now what if we have a point for the center that is not the origin? Well, here we have a center at the point HK. What this does is it alters the numerator. So the x value, it subtracts the h, and k is subtracted from the y value. And then, of course, it's going to alter your vertices and your foci. The other thing to notice is that with all of the ellipses, they have to be equal to 1. So the right-hand side is always equal to 1. Let's look at an example. We're going to find the vertices and the foci of the ellipse, and we're going to draw the graph by hand. So first things first, an ellipse has to be equal to 1. So we need to divide everything by 144. 16 is a factor of 144. 16 goes into 144 9 times, so this simplifies to x squared over 9. Well, if 16 goes into 144 9 times, 9 is going to go into 144 16 times, so the second term is y squared over 16, and this is equal to 1. To get it into true ellipse format, those denominators should be as squares. So 9 is 3 squared, and 16 is 4 squared. Okay, we have it in the true format. We notice that there's no number added or subtracted to our x or y in the numerator. That tells us that our center is at the origin 0, 0. So I'm going to plot my center. Now we can find the vertices. But before we do that, it would be good to know if we have a major axis horizontal or vertical. And the way I always do that, I look at the denominators. Which one is larger? Well, 4 is larger than 3. 4 is below the y variable. So this tells me that it's major axis vertical. Or I'm going to have an ellipse that looks similar to this. It's kind of stretched up and down. So it's longer along the y-axis. Now that I know that, I can find my vertices. My vertices will be of the format 0 plus or minus a, 2 points. And a is this value that's below the y squared. So I have the point 0, negative 4, and the point 0, 4 for my vertices. So we can plot those. There are the vertices. Now let's plot the foci. And that is 2 points, and those points are 0 plus or minus c. Well, what is c? C squared is equal to a squared minus b squared, where a is your larger denominator and b is the smaller denominator. So c squared is equal to 16 minus 9, or c squared equals 7, which tells us that c equals plus or minus the square root of 7. So our foci here are going to be the points 0, square root of 7, and 0, negative square root of 7. Okay, technically we can graph this ellipse with what we have, but I like to also throw in those x-intercepts. because the x-intercepts help me do a little bit better of a job graphing, and we all know that I can't even draw a circle. So your x-intercepts, well, your vertices were your y-intercepts here, and those were found from this value that's below the y squared. Well, the value below the x squared will give you your x-intercepts. And here, that would be the point -3, 0, and the point 3, 0. Now that I have 2 extra points, I have a better shot of connecting them and actually getting something that might look like an ellipse. Not too bad. So we found the vertices, check. We found the foci, check. And we were able to draw the graph of this ellipse. I know there's a lot to remember about ellipses and the different standard equations. I don't think you need to memorize it, just be familiar with it and be able to quickly pick out which one you have. So where the center is and if it's a major axis horizontal or vertical. Still have a question or come across a problem you need help with, leave it in the comments and I'm happy to include it in a video for you.